Hi there, welcome to this last video. Here we are going to address a little bit plotting. So assuming that we all know how to use XFOIL and we get all the output files, what we're going to do here, we're going to show you an alternative, or one action to do plotting. So stuff like this, your polars and curves, two curves together, changing axes. So we're going to do this using Python. I'm going to show you this, but remember that for your homework you can use any software, any plotting software, or even Excel, or you can take this screenshot for XFOIL. I don't care, but let's do something a little bit more professional. So the important thing that I'm assuming that we have all this data. So the data that we're going to deal with is the airfoil coordinate. So just to show you how to plot the airfoil, it's a straightforward XY, but probably will be important to have proportional aspect ratio, stuff like that. Then the outputs, okay? So you will have the outputs, and we're going to use two outputs, okay? So first, the traditional polar. So see that we have CLCD, and then we're going to plot also CM, but also if you want, you can get CDP, pressure drag, and also the skin friction drag, that is this minus this. And you can also plot transitions, up to you. You are going just to plot the coefficient CLCD, CM in function is alpha, and also we're going to plot pressure coefficient. Okay, so remember that we can save that one. So I save it for one angle. Okay, here you have alpha 0 with this Reynolds, and see here that you have the x coordinate and the values, x, y coordinate and CP value. Okay, so in 2D also you can get the airfoil coordinates for here. Okay, but what is interesting that when you save this data out of XFOIL, you're going to get like this, the whole airfoil and the distribution. But if you want to do the plotting like in XFOIL, splitting since like top and bottom surface, it might be a good idea to manipulate your data, the output data. So see here that I did already that manipulation here. I will open those files. So I split it. I know what is my coordinate. So the top surface goes from trailing edge 1 up to the leading edge, and see that I know that I stop it here. I get my coefficient there, and the same from the bottom goes from. So you can do this manually, but also you can do it using your program. Okay, you can use some logic and conditioning to know where to stop, but I will do it in this way. Let's say this way, or the brutal way, not very elegant. Okay, so as I say, in CP also you have airfoil coordinates. Okay, so maybe we don't need to open that other file, but just to show you. So see that pretty much is the same coordinates that you have. So let's access this data using Python. The alternatives that I show you. By the way, if you don't have Python, I recommend to use this version. It's called Anaconda Python. It's very powerful, and you have it for all operating system, Mac, Windows, and Linux, and also other operating systems. So as you go here, individual, here you can download, okay, according to your operating system. So here you have the major versions. So it's a very powerful tool. It's free. So I recommend it also. It's a very it's important skill, okay, so you learn a little bit. So the first plot here, I'm not going into details, okay. So this is Python, but where I'm using something that is called a Python notebook. Okay, so I can program. I can get my Python scripts in the web browser. Okay, it's very handy. Okay, but you can do it also in a traditional text file. Okay, so in your text file you write your commands and then you execute Python. But for some reason I like it here. So these are standard commands that you have here. I'm not going to go into details. And we're using this library, these two libraries, Matplotlib and NumPy. Okay, so as you go in the internet again, you're going to find a lot of information how to use that one. So I'm not going into many details. It will be up to you to look for things, but it's very well documented. NumPy is also another interesting library. Okay, so as you go on the internet, you will find information. This is for array manipulation. And there is another one, SciPy. Very powerful also. So here you have documentation tutorial to do it, so I'm not going into details. So basically what we're doing here, okay, just calling the library what I want to use in the library. And something important to execute, these are cells that you have here in this node. But to execute these cells, you need to press Shift Enter, and you execute. See that you're executing. Okay, Shift Enter. Also here you're going to cell and see that you can press Run All, and it will run everything. Okay, so always look at the options of Run All, or you can get a single cell here. Okay, so you have a few options there. For the purposes here, from time to time I will do Shift Enter or Run All, so I want to show you the immediate script. Here at the end also showing you the specific versions that I'm using. So the first plot is the common one, this one. So see that here, CLCD, this is the polar plot, and very standard one. So see that we're putting grids. So here you have some comments how to enable disable grids. Okay, so if you want to play around with this script, for instance, I'm plotting this one. Let me comment that one. The comments here are using hashtag or numeral or pound, whatever you call it. See that now I'm using, so the important thing is that I'm reading my data. So here when you read in data, you need to give the relative path. So I have an script, and in the same directory I have this information. Okay, so it's a relative path, and see that I have this option is keeping the first 12 rows, and once you open that file, okay, any of this, see that you have 12 rows there that you can skip. Okay, so you can manipulate everything when reading. So see that you read this data and you call it data. This is your array. So you're going to access columns here now. So it will be columns 0, 1, 2, 3, 4, 5, 6. And then you just choose which one you want to plot. Okay, and the same for the airfoil. Okay, so in the airfoil, skipping just one row. And look at that, here we go to plot and see that we're reading this array data and just accessing everything vertical column of the array. Let's say all lines column 0, all lines column 1. Okay, so we know that column 0 is alpha CL, and this is what we're plotting. So to proceed now, enter, and see that now you have your data. Be careful that you need to change the names in the axis. So here also you have how to give different names. You can put LaTeX in Python. Okay, so there is no problem to add symbols on that sense. Okay, so this is how you get CL. Okay, so it's very handy. Okay, very easy to use. Here you have comments to play, font size and that stuff. If you want to save the figure, this one, so just erase this comment, we'll save it with this resolution. There are many formats, and send it again. And in the directory where you have that Python script, okay, in my case, see that I'm running in this directory, I have everything. You have your file there, and then you can do your your post-processing and have your figures, just nice figure. Okay, so this is the single one. Okay, so you can do it for CL, CD, C alpha, but you can do more elaborate stuff. So for instance, the next one that I want to show you is this one. So look at it. In this one, we're plotting two coefficients in one plot. Okay, so here we're using a common axis here. So probably it's not a good idea, because maybe this one will be way much larger than the other. It's difficult to read. But to do it, see that you access in the same way the data. See that the columns are now column 2, 1, and change the name, and nothing changed. The rest is the same. But to make things a little bit more elegant, we can have different axes. And see that we have the legend here. Also, you can enable legend there. So see that in this option now, we have two axes. So the left axis CL, right axis to CD. Okay, so this is much better. And here you have alpha. So here you have the explanation how to do that. So it's a little bit tricky, but see that the thing here is that you need to create a second axis. Okay, so this is an option that you declare your plot. Okay, and see that we're having a plot in one axis and then another plot in another axis. So it's twin X to replicate that one. So now that you have the second axis, so see that the first plot is the blue line. See that you can assign colors. It is using this x-axis, but if you want to access now the second axis, see that you call it AX2, and then you plot the drag or whatever you want in the other one. And now you have different scales. So to give names and bounds to your domain, you will need to access the specific axis. So see that you have axis 1 and 2, and see here that this is what we're doing: bounds, plot grid, legend, Okay, so it's a little bit tricky to plot the legend in this case, but this is basically a template, and that's all. And then tick marks, if you want to add this tick mark, so that you have it there. So this is a little bit more elegant. I like this one more, but you can do even more stuff now. So now let me I'll show you also here is that some array manipulations to extract values. So remember that we have this data, this array. So it's the data array. Okay, so see that if I do like this, it's showing me all the data that you have in that column. As you go to the other column, you have your data in those columns. You don't put anything, okay, let me put like this. It will give you everything that you have in that array. So you can manipulate, as you can see, these arrays, you can manipulate it. So for instance, let's say that I want to find let's say the value, the maximum here is CL max. I can go like this, maximum value in column 1. I know that column 1 is CL. So it will give me the maximum value that you have in that array. So see that, as this is that, you have that value. Okay, then here you have a stuff minor elaborated. So in this case, I want to find the index where the value is equal to 0. Okay, so basically I want to find the index when alpha is 0, and then I will interrogate my array to know what is the CL value. So see that here, you do like this, you save that value in X, and actually it's print X. So it's telling me that the value is 10. And I know that in position 10 of my array, so as you go here, you will have 0, 1, 2, 3, 4. This will be 10. Okay, here you have that, and then you can get that value. Okay, so it seems complicated. I'm probably trying to overcomplicate things. It might be an easier way. I know there are easier way, but just to show you, okay, the basic stuff. And then there is something interesting. For instance, for us, I mentioned that it's very important to know the angle when CL is 0. Okay, CL 0. So that angle sometimes is not easy to get from this plot. We can get it right ahead for next one. So what we can do here is just we can create. So these are discrete values. Okay, so what you can do here is just compute the intersection of these 2 points with this one. It's a little bit tricky. So to do things a little bit more automatic, we can create an interpolation function, and then we can kind of find the roots of that one with this axis. This is that. So this is what I'm doing here. So see that now we're using this new library, SciPy, using this interpolate, and see that what I'm doing here is creating an interpolation function using these data sets. Okay, 0 and 1, AOA and CL, and then I do the opposite one. Okay, this is CL and AOA. Okay, so I have 2 interpolation functions. Then I create here an array in X, okay, that goes from -10 to 25. So these values needs to be the same bounds that you have that you are using for interpolate your data. And see that I have 100,000, 10,000 values or to use that one. And then I put it here, and you have your new function. So X new, Y new is your new function, interpolated function. And just to show you that here, I'm plotting that one. Interpolate is the continuous line with the original data, and you see perfect fit. But the interesting that this f in 1, 2, this is a actual function, interpolation function that you can interrogate to get that intersection. So for instance, I get f in 2, and I say f in 2 0 means give me the value when CL is 0. It's telling me that when CL is 0, you have this angle of attack, -3.13. Okay, so this is how you interrogate the data. You can do more stuff. Okay, so here I show you the basic. Okay, but we know that that information. But why do we want that in here matplotlib? Because we can also add annotations here. So for instance, see that then if you want to have your nice plot and annotate, maybe you will like to know these values. Okay, so you can get right ahead those values here using this function. So see that it's exactly the same, but here's how we annotate. Okay, it's pretty much the same as the previous one, the first case, and but with annotation. Okay, so see the annotation, you give the values. Okay, 0, 0, 3 in this one. Okay, so see, and this one also, and then also you give a position of the label, so you can do more elegant stuff. So as you see, I just show you this basic. It's just up to you to do these plots. Okay, so these are these polars, and let me show you a more general one. I really like This one, this is the one I call it the extended polar. Okay, so I see that you can have many plots here, okay, but if you're doing a report, it will be figure after figure, but you can concentrate everything, put everything in one single plot, which is this one, the extended one. So see that in this one we have all the information: lift coefficient, drag coefficient, moment coefficient, and the polar. Pay attention to the colors of the axis, okay? So the polar correspond to this axis, and lift here, so it's the polar CLCD. So you look at this one, so you're going to check for drag. See that the drag is this axis, moment this axis. So this was very handy. You have everything in one plot. It's relatively easy to read, okay? So here you can identify all that information. This is a little bit tricky to do, so see that it's a long script. Okay, not going into details, but you will understand it easy. But the idea here is that, see that you need to create several axes. So see that we have twin 2, that is this one, and then a twin 3, which is this one, and then you shift it a little bit. So here you have all the steps how to do this, but this is a template, okay, that you can use. And you see that here, this is reading the data coming from XFOIL. Exactly if it comes from XFOIL, it works. So see that in this case, I'm reading I generated my polar, just read that out of the box, and you can do this plot, okay? So then, if you want to save it, you have it here. And the last plot that I want to show you is about CP. Okay, so these are our polars, but then we have this CP distribution. Also, you can have the friction coefficient distribution, all that stuff that we saw in the video. I'm just going to show you the CP. So it's the same, okay? So remember that now we need to read the CP data, okay? So you should have that in your outputs here, CP, and then we split it in bottom and top. Okay, so see that we have it there. We're reading the other data, but we're not going to use now the other data. The airfoil maybe. So the first plot is this one, just to plot the airfoil. Okay, so see that we're accessing this data. But what is important here is this option. Is the aspect ratio is equal. So if I disable this option, okay, let me run everything. Okay, it's loading everything, and let me now I comment this one, enter, see that it's not proportional. So it's right, this is the right geometry, but for, let's say, plotting purposes, it's better to have your axis now proportional, which, by the way, I disabled the axis. So see that PLT axis off, you comment there, put it to on, you have the axis there. Okay, it's the same if you put it here on, nothing changed. Okay, shift enter, remember. So if I go here, equal, see that now this is proportional, this axis, okay? So it's up to you, okay? It doesn't matter, but yeah, the two main things visually attractive, it's better to have everything proportional. Okay, so this is your airfoil, and then in next plot, see that this is CP distribution. Okay, so we're reading CP, we're reading the whole data in the airfoil. We are not accessing now the top bottom surfaces. Okay, but see that the plot is pretty much the same. Okay, nothing changed. You have your axis. Okay, see that I didn't put any grid lines. Okay, later we keep reading here and you see more elaborated. So for instance, here we have subplots. Okay, we have a plot 1 and a plot 2, and a subplot here is this one. So it's very cool, very nice. So you have your CP here and your airfoil down here in the bottom. If you don't want to see, for instance, see that here we have the axis, now the box. If you don't want to see the box, just go here and you have this option. Now you can turn off that box. Okay, but what is important, remember here that you need to turn off the right box or the right option. So this one is axis. Now it's everything. Okay, I think it should work. Okay, so see that switch off all the axes. Okay, but sometimes you might want to just turn off one axis and you just say it here. Okay, and this one is everything, but also you can have the individual axes there. Okay, so let me put it like this. Then this one is a little bit more elaborated, or not more elaborated, but what I'm doing here is just putting the airfoil in the same plot with CP, and see that now we have twin axes here. So see that in this one is the airfoil thickness. It is proportional. Here is CP distribution with the grid line. So relatively easy, okay, in the same way. We're not using subplots, but here you see that we create the second vertical axis, the right one, and then you choose where to plot. So see that we're plotting here, left axis, then you plot in the right axis the airfoil, put it to equal aspect ratio, and give legends and tick marks and that stuff. And this is all. pretty easy, pretty nice. Okay, here that see that there is some transparency. Here you have that alpha. Okay, the transparency, but again, remember you have the help. Okay, so I'm not going into details. And the final one is this one, is another very elaborated one. So pretty much the same, but see that now we access the data top and bottom. So see that now we add colors that like in XFOIL, and you can do the same with the airfoil. You can access the airfoil data and give it different colors. It's up to you, but here I think it's okay like this. There is some transparency, and see that we have two axes. And now pay attention that the CP axis is inverted. So far we have it like this. Okay, but as I may say during the lecture, it's very important to pay attention to this axis, and sometimes for better, to understand better, just this is a, let's say, kind of a common practice now. When plotting this CP in airfoils, just put the invert in this axis, invert this axis, and you have it like this. Okay, so to do this axis inversion, this is a very simple command. Okay, so as you go here, I want to invert which axis, this one, because we have double axis, and see that it's all inverted. So comment that one, see that you have it like this. Okay, but let me go back, and that's all. Okay, so your colors, let's see that are also adding the minor ticks. Okay, so here you have how to plot minors and major ticks, how to add grid lines, everything in your plot. Okay, so it's a little bit more elaborated. You can read it very easy, and see also here you can add legends. Okay, so you want to point out something here in your plot. And again, here these are the versions that we're using. So this is all. Okay, basic plotting. Okay, in the video description you will have the link to download these scripts. The data you already have it, but also in the same place that you download that, you can download this exactly same data, but the data as it is coming from XFOIL, you can use it here. So all these scripts are located in GitHub. Okay, this is something just to save now this small program. So you will have the link there. So see that here you have your scripts. You can download everything, and you have the data just in case. What is cool about this also is you can click here and it will show you the script. Okay, you are not going to be able to run this script, but it's just going to show you here what you have. Okay, and you can do copy and paste to your computer. Okay, so just check the video description, you have that, and if in case that you don't have the data that you already have, also here you have all the airfoils and everything. Okay, so that's all. Okay, thank you very much for your attention. Okay, see you next time. Bye.